I am from the Center for Astrophysics in Cambridge, Massachusetts, is actually where I'm from. John is down here in the city, and he's an app developer, and I am actually a librarian. So I'm the head librarian at the CFA, and John helps get things done here with CUNY. And the reason why we're here in front of you today is because we, with some serendipity, found ourselves actually taking a class together. We're both finishing up our master's degrees in data analytics, and we were given projects pretty frequently that asked us to work in groups. And about a year ago, John and I started working on a project that made us notice a pretty big problem. So we were in a course on network analytics, of all things, called web analytics, just to confuse everyone. And as a result, we were asked pretty often to work with packages that really were not optimized for visualizing networks, because we were being asked to work in Jupyter Notebooks. And so in these courses, we were being told, here, turn in your Jupyter Notebook, put your markdown in there. And a lot of the time, the culmination of the analytics that we were doing would ask us to create a visualization of what we had done. And oh, I should also speculate. I put these in a little bit in the wrong order. We decided we should focus on this problem that you can't really make good network visualizations using the packages that we were being suggested to use in Jupyter, because it's really important. So the more that we did these exercises, the more it became obvious that it was really hard to actually show the instructor, or really anyone in the class, the impact of what you were seeing, because all you had was a couple of numbers. Either that, or you'd have to kind of jump ship completely, leave the Jupyter Notebook, do something with JavaScript, do something with Gephi, do something with Cytoscape, one of these other packages where there's a pretty high barrier for entry, essentially. You'd have to learn a completely different protocol, different way of working, and then you'd have to find some way to kind of screenshot it and put it into the Jupyter Notebook. That's clearly not ideal. And on top of that, it really hinders your ability to use the network visualizations to actually infer things. So when you're doing analytics, when you're working with a network, if you can't really see what you're looking at, it's kind of hard to know what questions to ask. And it's also difficult to perceive trends that might not be obvious at first glance from looking at your numbers. And so with that in mind, knowing that network visualization is important, not just to us in school, but to scientists and anyone really looking to work with network objects, we decided to try to find a way to make it so you could give data scientists and researchers and other people who are using Jupyter as their primary kind of way to share their work, give them something that would help them make useful and engaging graphics, so that you can both make inferences and really present your work without making people leave the platform that their work relies on. So we think it's probably better, rather than completely reinventing the wheel, though, to do this, to leverage some tools that are already optimized for this purpose. So there are already really great packages that exist in the world to help you create graph objects and help you visualize graph objects and work with them. And the goal isn't necessarily to make some new thing to put on top of the thing you already have. The idea was more to make it so that you wouldn't necessarily have to have that big lift. So you lower the barrier for entry into using these tools without making a whole new kind of proprietary layer on top of what we were doing. So try to connect them to the notebook. And I know that I see some heads shaking in the room. NetworkX is probably something a lot of you have worked with if you're interested at all in network objects and work in Python and work in Jupyter Notebooks, which I hope is probably most of you. Otherwise, I'm really not sure what you're doing here. Maybe you're masochists, or maybe you're really bored. But NetworkX is a really popular library, a module in Python for doing analytics. But when you work with this package, you immediately start to see how it goes wrong. So this is what I call ugly plot. This is just not very useful. So this is really what we were working with initially that prompted me and John to actually start working together and talking about this, because I have something to say here. You have no idea what it is. And it's very difficult to work with, and I frankly think that it's kind of a waste of time to try to make this pretty, because the amount of legwork you're doing to try to work with this natively could be put towards learning an entirely different language that's really built for this problem. And so we thought we could make something better. And I know it's kind of hard to see there because the color on the screen isn't that great, but this is a screenshot of the little app, side-by-side app that we built that you can launch from within the Jupyter Notebook. Can you see it better? Did you zoom in? OK. Well, we'll give you a demo at the end, so please don't rely on squinting at this. But we tried to create something using tools that are already optimized for this purpose to try to do something I think that's quite a bit better than that first red dot blob. And what we made it so you can do is you can work with your NetworkX object in the Jupyter Notebook, and then you can run a script after doing a couple of simple installation steps that'll let you launch in another tab in your browser an interactive network tool that'll let you select and zoom in and play around and move around your network, and then create your own data set, a subset based on what you selected and the measures and the attributes that you may have appended to your nodes, and export them as a CSV file. I think that that's a lot nicer. And I'm going to keep walking back to the middle. And so the last year when we started talking about this, initially it was a standalone kind of prototype just for a class. And this semester, because we're still in school, we decided to actually integrate it with Jupyter. So it's not a standalone thing anymore. And it's what we're calling IPySigma. So it's a little bit of a hat tip to the IPython nomenclature, so to speak, and because it makes use of SigmaJS, we thought we'd integrate that. And so what I want this to be seen as is more of an extensible prototype. So it works. We have more that we think that could be done with it, but it's really more of a framework and a line of reasoning that I'm hoping to share with you all and to get your feedback and input on. So without further ado, what are the pieces? So if we don't want to reinvent the wheel, and we're really trying to not make people leave their environment, why did we actually decide to stick with Jupyter? As not only is Jupyter, I mean, I'm kind of preaching to the choir here, but if you want to have something that makes it so you can share your work easily, and that you can kind of containerize everything that you're working on, and you value reproducibility, this is really the platform we should be paying attention to. So rather than trying to make something that works with a different development environment, we really thought that sticking with this would be best, especially in the educational setting that we were in, because we were the students having the problem being told to use Jupyter. And we decided to use a JavaScript library called SigmaJS. So Sigma, if you have not heard of it, is just an open JavaScript library that's specifically dedicated to doing network visualizations. It's optimized for that purpose. Excuse me. And so unlike libraries like D3, which is great and extensible, this is really just for that purpose. So we definitely don't want to try to take something as big as D3 and shoehorn it into this. We want it to be a little more lightweight. And so John is actually going to talk a little bit about what this is that we made and how it works. And you can see already from the graph, though, we tried to make this really pretty clean. So it's not very heavy, and I think that it's an extensible protocol. So take it away, John.
Yay. OK, so this basically, here's your standard technical diagram of how things work, I guess, a control flow or whatever. So on the left-hand side, we have the Jupyter Notebook, which we're going to be using as sort of like, which is our front-end tool of choice for doing the analytical side of stuff. And we can see it connecting with the server, with the Jupyter Notebook server. And then, behind everything is, of course, the kernel, where our, API is sitting, along with everything else you've loaded into Python while you're doing your work. And the idea is that our Node.js server is actually going to connect to the, the notebook server directly, and we're using the tools provided by Jupyter Lab services, which are a set of JavaScript. It's a JavaScript API. And from there, all of those smaller connections are just WebSockets. So you actually just open a bidirectional line of communication with the object that you're working with. And from there, you can spin up different browser tabs with the graphs that you want to study. What else is there to say about that?
What else is there to say
What else is there to say about that?
So you can see the idea, if you go back just for a second. So the idea here is that when you're working in your Jupyter Notebook, you could open up many tabs.
Right.
So you're not just working with one graph object that you put in a tab. You could have another tab, and you can compare.
Right, exactly. And this is kind of the design as it stands now, and we're looking to make it a little more robust by allowing multiple graphs within a single browser tab and this sort of thing. But this is where we're at with it right now. Yep. And it's using a WebSocket to open up hopefully bidirectional communication, even though right now there isn't a lot of that going on per se. So we're kind of I was building this with the idea of where it will be, where it can be eventually, with more work.
Yeah. So. And so I will also reiterate the caveat. We started making this as a school project. So those of you with a lot more JavaScript experience than us and ideas.
So sorry about all the jQuery and all that other stuff. All right.
So, but we're using all open protocols that are all really common. And in order to get started with using this tool, these are all of the instructions you need. We have a GitHub repo that basically has everything built in. You need to follow a couple of different steps just to make sure your environment is set up well enough so that you have Python and Node configured properly. And so if you're running on a different operating system or something like that, this may have to be tweaked, but for the most part, this is pretty much vanilla. Yeah. And that makes it pretty nice. And as we've been alluding to, there are some limitations. So right now, it only works with NetworkX graph objects. Like I said in the beginning, those red nasty things, the way that we see it is you could basically augment the source code to make it so it could ingest any kind of graph object that you can throw at it. If you have GraphML, if you wanted to import a CSV and then turn it into your own kind of object, I think that you really could do that. Also, refreshing the browser can cause problems.
Yeah, well, that's just basically, if you have a WebSocket connection, it'll just break it, and we don't have code in place yet to deal with that scenario. So save often. And that's the kind of thing that we know there are solutions for. But basically, we've looked into using in-browser memory, something like Loki. But I think it's a little bit above our heads right now. But we know that there are potential solutions out there. We also didn't use a development framework. So. Well, yeah, there's no, In the future, maybe moving this to Angular or something would make more sense. But the original version of this was actually just a Flask application, so it made the most sense to port as much code from that as possible. So, anyways. Yeah. So here I'm gonna try to oops. Oh. Not yet. Not yet. Okay. Go back. Wait, this one. All right. Yeah. So there's still a couple more limitations. Sorry.
Ideally, as we alluded to, we'd like to store multiple graphs in a tab. So when we do the demo, you'll see that you can name a graph object in a tab and bring up that graph. Ideally, you would just be able to bring up the other graph that you also named to yourself so that you can show them both in the same browser tab, but that functionality is just not really there yet. And it has a few hacks built in. So I'm sure you'll find them. It's not perfect, but we're really glad for what it can do already. So go on.
All right.
Yeah. So we're going to show you IPySigma in action. But before I move forward with the demo notebook, there's some definitions. So I mentioned I'm a librarian. And one of the things that John and I were actually exploring and working on were some questions I had related to publication tendencies with my community. So I don't know how many of you are in scholarly landscape or how many of you really work in publishing, but it's useful for scientists to know the impact that they have on their communities and for them to know for us to see trends in their behavior. And one of the funny things out there in the scholarly publishing realm is a phrase called impact factor. So this is a measure that's frequently used to kind of show the impact a particular article has in the field. And so that's a number that's assigned to the journal that you're publishing in. And a lot of the time, you're really incentivized to publish in a high-impact journal so that you can really push and show, like, look, I should get tenure. Look at the impact I'm having. And it's like a feather in your hat. I published in Science or something like that. And the costs of those journals are typically exorbitant. And so one of the things, the conversations going on in libraries right now is the push towards more open publications and trying to figure out different ways to measure the value of contributions of our communities so that we can really, show what we're up to. The other bit of jargon, so remember impact factor is assigned to a journal, and the degree centrality. So if you're in network analytics at all, or if you've really done any network analytics, there are a lot of different centrality measures out there. But centrality measures, more broadly, help you identify the most important vertices in a graph. So the most important node in your big spider web. And those are different ways of thinking about impact. So what's the most important node in a graph? Or what is the impact factor of the journal? So that's going to be kind of the foundation of the demo, so it doesn't completely make no sense.
All right, here it goes.
Actually, if you move over one more tab too, so.
Oh, was that it? Oh, I got out. I exited the thing, sorry.
Oh, yeah, so if you hit side one more time. OK, never mind, maybe I didn't put it up. Just remember the big hairball. I wanted to do a comparison.
Oh. Well, everyone can remember the hairball.
Yeah.
All right, and it's running. OK. So this is sort of like what the notebook, or this is our demo. Welcome to the demo. No. So basically, we're just importing this object here, and that's like acts as a controller and sort of a daemon, although it doesn't have all that functionality built in yet. But it essentially manages the Express server and makes all the WebSocket connections for you so that the graphs know where to go. One thing, OK, so you basically, you load these guys. I preloaded this. You would run each of these cells. You import this guy. This is the main class. And you got to point it to the wherever you install the Express server part of the application. It could be anywhere, and you just have to point it to the right spot, basically. In our case, it's just, I'm in the root folder, so I'm just pointing it there. Yeah, so all that's going to do is, it fires up, it, opens a subprocess and loads the Express server up and gives you a PID in case something goes horribly wrong and you need to cancel it. So from there, yeah, so basically, in terms of when I was thinking about designing this, I wanted to keep this as simple as possible. I didn't want anybody to have to use our own classes, subclassing the graphs and subclassing anything from the graph, or having to wrap the NX object inside of another object, kind of having to bootstrap it. Like I felt like that's like less intuitive, for maybe, I didn't want to disrupt like the workflow, like you have a workflow going and you're doing some analysis, and all right, now I have to use this library, and you got to, add a bunch of lines to the code. So I was trying to make this as like smooth a thing as possible, so it didn't disrupt anything while you're in the notebook. Because like when we were working on this project originally, one of the first things, Daina mentioned, like we were using Neo4j a lot, which is cool, and it actually gave us the idea for the project. But in order to do that, we had to, basically stop what you're doing, dump everything out, and then load Neo4j, and then load that, and you have to have a server running and all this other stuff outside of the notebook. So
SQL was involved.
Well, not SQL. Well, SQL could be involved if you wanted, but yeah, you have to not everybody wants to learn the Neo4j. I forget what the language is called, but Cypher, right? Thanks. Yeah. Which was kind of, it's cool, but I found like it was distracting us from doing what we needed to get to do. So there we go. So our data set loads. So we basically, it has to adhere to a certain schema, to get the most out of our app. So we're always going to pass in a label, and we're going to set the node attributes. There's always going to be a label, and there's always going to be a node type. And if you don't do that, it will still generate a graph, but you won't have some of the features that make this cool, which is like different colors and things. Yeah, so, and this is like what an edge list would look like, just to show you that this is just a raw NX object. So then all we have to do is pass that object in along with a key name, and use this connect method, which I already did, I believe. So all we have to do is run this, and then we get this screen, and you can put in a graph title here. This is more for future functionality, because the idea would be within each browser there would be a memory cache, and you could cache each graph via its name in the browser session. But I haven't gotten that far yet. And so now we just load, and boom, and now you have a nice graph, and you can look at it, and you can zoom in, and you can click on it, and you get, this is all functionality from Sigma. Pretty much you get out of the box. I mean, there's a few plugins added to this. So the gravity plugin, and then we have a little Explorer object that you can toggle around and poke around and see who's who in your graph, and it's just a lot. Basically, it's just a lot nicer than looking at a red hairball.
So I should say that the data set that we just showed in the demo is the same data set that initial red hairball was made of. It's a very, very general search of the NASA astrophysics data system for the most cited, most recent 50 papers that are on stars. And so what you can see, though, is if you zoom out, when you hover over, so like this big node, John's steering, you can see that this is the Astrophysical Journal. And you can see that when you double click on it, and you can see at the side, you've got our degree centrality, it's got a page rank, it's got betweenness. Those are just things that we already decided and calculated out, but you can add your own attributes to these things. But you can see that the measure of the degree centrality is pretty darn high. And although the white balance on the screen is really making it so you can't see other nodes, you can see them, I promise, in the browser. We should have tried this on the screen. But if you select, there's many smaller ones. So if you look, I can't remember.
It's around there. Yeah. What, you're looking for nature,
the
right?
nature one.
All right.
So I think it might be a little more disconnected or down. It might be so one of these nodes, which we didn't just automatically put the labels on, is the journal Nature. And it's much smaller, I promise, than the after. There it is. So there we go. So the Astrophysical Journal, so if you remove the middle one, the middle one from the, I mean, I guess it doesn't matter if you remove it. Remove the row. But you can remove the row if you didn't.
Hey, look, you can remove the row.
So you can unselect something.
Yay,
but
JavaScript.
This is sort of the kind of case that sometimes I'm looking to make and looking to promote, and it's pretty easy to see. When you look at Nature compared to the Astrophysical Journal, you can very clearly see that the centrality measure is higher, meaning it is a much more impactful node in the graph. And it's also much bigger. So you see many more collaborations going on here, and you see that that publication is impacting the overall field much more dramatically than the Nature node is. However, I'm going to make sure I have the numbers right here. When you look at impact factor, so the numbers that are assigned to journals by publishers, Nature has an impact factor of 40.137. But Astrophysical Journal has an impact factor of 5.014. So according to one measure, the journal Nature is 8 times more impactful than the Astronomy Journal. But I'm trying to make the case here that this is clearly domain specific, and that when we're talking about tenure, we're talking about giving postdocs the ability to really promote their work and to talk more about what they're doing. We shouldn't just be kind of encouraging these high impact papers. We should be giving more credit even to these journals that clearly matter more in their field. And so the tool here, I think, is a really nice way to lower the technical barriers and a little bit of the intimidation, too, for making an argument. So I said I'm a librarian, and I like to think that I have some technical skills. But I know that there are a lot of other people in my field who don't necessarily have the same capacities that I feel confident with. There are a lot of other fields, too, where people use networks, and they have to pass off their ability to actually make visualizations to others. That can be expensive. It removes this person from the ability to make those creative inferences on their own. And I think that if we can lower the barrier without giving people handicaps a little bit more often, that you'll have more voices in the conversation, in the development conversation, and really being able to contribute more to these problems and to really be more actively engaged. On top of it looking pretty. So you can customize the colors, and you can name your graphs whatever you want, and you can export all. So if you wanted to export all of these nodes, you just select the ones you want. You can export them as a CSV file, flat format, and you can send them to whoever you need to send them to. Or you can keep them for yourself, because then you've created a flat file with those measures that you need, and you don't even need to hand off your Python notebook unless you want to. And if someone wanted to reproduce what you did, I mean, it's not as challenging. Still, you'd have to kind of select the nodes you want to make the graph, but they have a list of those things. So I do think that it's still pretty reproducible. And we're at about 30 minutes now, and I know we have 40, and I wanted to kind of get your feedback on this, if you have any, and questions, if you have any. Leaving a little extra time for questions. And if we hear crickets, I'll just get off the stage and we'll be done a little early. So.
From the graph view, do you have an export to PNG or something for a static view?
Not yet, but that's a good idea. So right now, okay.
Yeah, we don't have much export. Oh, yes.
So is this open source?
Yes.
Yep.
So it's on GitHub with an MIT license.
It's in my repository. Just grab it. Feel free to play with it. It's cool.
Oh, so if you.
Oh, did you put a link in there?
Yeah, the link is
sorry.
in the. If you go back to the slides.
All right, I got
the demo
the slides.
page.
That's cool. Wait, where is the?
Yeah, we're doing this. You can't actually see it on the screen. This is kind of funny. So wait.
All right, you know where this is?
The other.
Oh, the
yeah,
repo.
First clone the repo. That's actually clickable. Oh. Sorry.
Yeah.
So bsnack000/ipysigma-demo.
That's my handle. Sorry about that.
Yeah. So there was a question here.
Or you can just. I'll give it to you after too. That's cool.
Have you considered linking this to the rest of the widget ecosystem?
Yeah. No. I've thought about that. That's something I personally haven't explored. So the answer is that's a really cool idea. And I actually don't know much about the plugin system yet with Jupyter. It's something I haven't experimented with. The reason I went this route was because when we were designing this, I wasn't sure. I liked the idea of using 2 servers and having it like as a separate app, so that if we, I wasn't quite sure yet, like what we would be doing with persistence and like maybe having a database off of that server. So that's why I didn't go that route in the beginning.
Exactly what you were trying to avoid initially?
Right. That's what. Yeah, I'm trying. Yeah, it was a lot of juggling, like trying to figure out like the right configuration, and it's just an experiment, really. I just thought it would be interesting to try to do. So.
Yeah.
Have you started to look at the data to see if the impact of the open source journals are starting to change versus the paid ones like Elsevier?
You could certainly do that exact same analysis with this tool, and I can promise you you can start to see the impact of open source versus the paid subscriptions, but it's a little bit harder to do because the data set that I'm working with I use the NASA Astrophysics Data System API to pull out the data, and the publisher isn't always obvious, and the impact of archive on the field is pretty dramatic. And so you can't necessarily see archive citations always in the, so archive is a preprint server that makes it so you can really just deposit your papers before they're all marked up by the publisher. And in astronomy and astrophysics, it's a really, really crucial resource. So it's a little harder to actually definitively say. Yeah?
Have you thought about integrating with GIF5 or Gephi?
Oh yeah, that was.
Well, we haven't thought much about integrating with Gephi. I know that I hadn't worked with Gephi in a very long time, and when I started looking back into it, it just seemed like another thing to have to learn, and I was working in school. So honestly, it's not been the kind of thing I've turned back to. I don't know if you've peeked at it much.
I messed with it a little. When we were working on this last year, when we were looking for solutions, like I explained, I ended up going with Neo4j to do some of that stuff, where if I was trying to do it, just because I could do it on the fly a little faster, and that's like what influenced this workflow, obviously. But yeah, nothing wrong. Gephi's cool. It is. It's like it's a big program, and you have to really spend a lot of time with it, And that was something where I was at. I wasn't I didn't have the resources or time to do that.
Now there are some Python bindings with streamer module.
Oh, I didn't know that.
Make it kind of easier.
Oh, that's cool.
Across the Java world.
Oh yeah, all right.
Add that as a GitHub
I'd like to learn about that. See, there's so many things out there. It's like you can't. It's hard to find them all. That's cool. That's really cool.
Congrats.
Okay.
Thank you. And I think we have time for just a couple more if anyone has questions. Go on.
I was just going to say, similar to this guy, I was wondering if you have thought about having this in the notebook. I think the widgets ecosystem that's been...
Yeah, maybe that's a good way to do it, is to just port it. Yeah.
Yeah. So.
Is there widgets? There's a Python library that's come out fairly recently called BQplot that has some kind of basic graph visualization.
Oh, cool.
So the tools are there, but I'm not quite sure if it has all the capabilities that you
Right.
wanted now.
I guess one of the things is I'm envisioning this at some point being something where you can really communicate with the object and maybe manipulate the object from the application window, right? So you wouldn't be, or maybe you could, exactly. A widget would probably work for that too.
It might be ideal for that.
Yeah.
Everything's kind of stateful. It's really easy to access.
Cool. I'll check that out. That sounds great. Awesome.
Okay, and go on.
Is it just Python 2.7 or 3 also?
I can't hear you.
Oh, it's I did it in Python 2.7. I don't actually.
You have a great many people that design for Python 2.7, but normally people do it in Python 3 or.
Oh right, yeah. I guess it is in Python 2.7. Sorry, that's just like what I'm used to working in. But yeah, we should probably port that. Oops.
So,
yeah.
Answer is not 3.
The answer is not 3. Sorry.
And okay.
What was the total size of the graph that you had there in terms of nodes and edges?
How many
What was
is
that? I don't know.
I think it's 50 papers, and all of the authors affiliated with those 50 papers. So.
could probably dig in there and look it up. I can look that up for you.
We can follow up afterwards. It's
Yeah.
not a... So,
it wasn't huge, but it was sizable.
Yeah, so the thing is you can... I think that this is more of an existential problem in network visualization, the scalability of any kind of tool for that. But I think for day-to-day, the people who this is really more going to help out are the people who don't want to necessarily jump ship from the Jupyter Notebook. And a lot of people who are doing their development in the Jupyter Notebook aren't really working with things that go beyond that kind of scale.
Yeah, I mean, when the older project we did that this was based off of, we did do some analysis like on a large island network with like, that had over 15,000 edges with like a lot fewer nodes, but that, I didn't want to show that because it totally crushes, you know, the browser. It doesn't matter.
Slow.
Yeah, it doesn't matter. It'll just
very
like,
slow.
It doesn't matter how many, you know, because you can give it as many edges or nodes as you want, but it, you know, if it crashes the browser, it's going to crash the browser. There's nothing you can do about that. So
Scalability.
Right.
And
I think that's good.
we good?
Cool.
Okay.
Thank you, guys.
Thank you.
Appreciate it. Thank you.